Hey everyone, welcome to NomadsBits. In this video, we are going to cover the topic first generation of computers. So let's talk about, before talking about a first generation computer, let's talk about what before the first generation computer, which is also known as pre-computer era. So in pre-computer era, we do calculation by the help of mechanical devices like Pascal line, abacus, and these devices are just mechanical. There's no use of circuit, there's no use of electrical components, only pure mechanics. So the key features of pre-computer era is no electronic component, as I told you earlier, use mechanical gears like lever and wheels, require human effort to operate, could only perform basic arithmetic operations like multiplication, addition, subtractions, and divisions. Before 1940s, humans used mechanical or electromechanical devices to aid in computation. This tool laid the foundation for the development of modern computers by introducing key concepts like automation, programmability, and binary logic. So these devices just laid the foundation of today's modern computer. And you know what? When in NASA, when there is no computer, NASA hires real human to perform calculation. So this is very intuitive. And moving on forward, we have another topic: first generation of computer. The advancement in first generation computer only occurred with the help of vacuum tubes. Without vacuum tubes, it is nearly impossible to create such heavy or create such a device. It's just vacuum tubes who help to perform calculations. Vacuum tubes are nothing but it allows electricity or electrons to pass through. When it flows the electron, it represents 1, and when it allows the not allow to flow the electron, it represents 0. This basic device helps to form complex logic gates which used to do calculation and process calculation. So um, in first generation's timeline was like 1940 to 1956, and technology used, as I told you, vacuum tubes. We use programming language as we use machine language as our programming language, and for memory we use mechanisms. Examples of first generation computer are ENIAC and UNIVAC. Features, they are very large. They are very large in size, and they consume a lot of power, produces a lot of weight, and they are also slow processing. But so far so good. They are the first generation computer, and it is totally made of electrical component and also some mechanical devices. But it is the first generation computer which helps to do calculations in a more complex way. And these computers are used for used in defense mainly, used in defense and scientific purpose. Not this these computers are not used for like personal computer. They are mainly used for defense and scientific. Now the question is how this computer work, like working of a first generation computer. So as we know, uh, first generation computer works in machine language. There is nothing like high level language and assembly language formed at that time. At that time, we use only machine language for giving instructions and data to the first generation computer to do calculations. So today as in modern computer, programmers use VS Code editor. Okay, for executing its program, for running its program, we use VS Code editor. So at that time, uh, our scientists or our programmers use punch card to give instructions so and data to the first generation computer. So we can think punch cards as a VS Code editor. Okay, that's a good analogy. Now the question is how punch cards actually work. So punch card are nothing but a card which contain instruction or program in machine language. So machine language are made up of only two digits, zeros and one, and we have to represent instructions in machine. So we have to represent zeros and one. How do we represent zeros and one? By punching hole. Yes, we punch hole, and it represents one. And if there is no holes, then it represents zero. And each column on the card usually represents one character, like a letter, number or symbol. So each row in that column represents a bit, a one or a zero. Hence, data was stored by punching holes in a specific location on the card, and that's how the punch card stored instructions and programs for the calculations of a generation computer. Now let's see how punch cards get executed by the first generation computer. So there is two process, two mechanism that how we read punch card, how first generation computer reads punch card. But there is one mechanism which is known as electromechanical readers. These readers use metal buses and electrical contacts. How it works? The card will pass through the reader. Underneath the card were electrical contacts or metal rollers. Above the card were tiny metal buses or pins. So under the card there is electrical contact or metal rollers, and above the card were tiny metal buses or pins. When a hole was present, the brush passed through and touched the contact below, completing the electrical circuit, and that represent 1. If there is hole and if there is contact of electrical, then it represents 1, and if there is no hole, no contact, equals to 0. Electrical was used to detect holes in the card. And the next mechanism to read punch cards is that optical readers. That means light-based readers. They were more modern and work like this. A light source was placed under the card. A sensor like photodiode was placed above. And when the light passed through a hole, the sensor detected it and it represents 1. And if there is no hole, the card blocked the light and it represents 0. So light was used in optical punch card readers, mostly in later system. Uh, in early system we had electromechanical readers, but after some time we start using optical readers, which is a light-based reader. So moving on forward, we have another question: what binary data we gave as input? So let me tell you one thing, that before moving forward, I just want to say you that in this video I'm trying to give you the glimpse how the first generation computers work, because it is difficult to explain you everything, that how initially first generation computer works, because it's very hard to, I don't say it's impossible, but it's hard to combine all those uh, topics or to cover all those topics in a single video, because first generation computers are complex. They require humans to operate. Like, this is not like today's computer that one human can operate one laptop or computer. It is like at that time many humans needed to operate that device, because that device is so large, so huge. So this makes nearly difficult to cover all the topic of first generation computer. So moving on forward, we have another question: what binary data we gave as input? Computers, as you know, computers understood only zeros and ones. So whatever data you gave, whether number, text, or instructions, code, had to be converted into binary form and then punch as whole into the card. What could you input in the punch cards? Programming instructions like machine code or assembly in second generation, obviously. Data for processing like number to add, memory address, where to store or retrieve values, command controls like stop, jump, store. Each of these was written binary and punched into the card. As we know, each column on a punch card represents one character or instructions, and each row was bit position like 0, 1, 2. Let's say you want to represent simple code instructions. Int a is equal to 3. In today's programming language, that means assigning value 3 to the variable a. These instructions can also be represented in assembly language as load a3. That also means assigning value 3 to the variable a. This uses in second generation computer, but in first generation computer, we directly deals with machine language. Therefore, we give binary data directly as like this form. That means same as load a3, and that may also same as int a equals to 3. Binary code like this binary code 001, 000, so on, and 11 expressed as first 4 digits of this binary form is reserved for operation code for load. That means simply operation, this 30 and 1 represent operation code for load, and 00 will represent register, and this 8-bit information at 8-bit binary form represent as 3. So combining all this binary form and give results as like this. And this means load value 3 into the register A. What is register? Register is a small high-speed storage location inside a computer CPU that is used to hold data temporarily during processing. But in ENIAC, accumulator works as a register. Therefore, ENIAC accumulator type is a type of register used to store temporary data. And as I told you earlier, that binary form 001 means load, because we humans pre-wired the computer control logic to respond that way. This is pre-wired, and this pre-wired tells us that this means operation code for load. This is also pre-wired, and this also represents register A. This is also pre-wired, and it represents the binary form of value 3. Now let's take example. When you wanted to add two numbers, one number will be in accumulator A, which is a type of register which used to store temporary value. The second could be in accumulator B, or entered via the input unit. The operation was done electronically, and the result was stored back one of the accumulators. No RAM, no cache, just register like accumulators connected by programming wire. This could be done by using vacuum tubes, hence vacuum tubes as a CPU in ENIAC. But the thing is, while in computers, we all data and store in a binary, but in first generation computer, all data is stored in processing decimal format. How? Let's see. Step 1. Binary input. External source input could be from punch cards, switches, control panels. Each digit 0 to 9 was easily entered in binary coded decimal. Example 7 as 01 or 0111 in binary coded decimal. Decoder converts binary decimal pulse. ENIAC had decoding circuits made from vacuum tubes, and the decoder activates one output line based on the binary input. So 0111 decoder activates 7 output line. That output line triggers the 7th flip-flop. Again, what is flip-flop? There are 10 flip-flops to represent the data 0 and 9 in the ring counter. Storage in ring counter accumulator. ENIAC store each digit in its own ring counter. Our ring counter has 10 flip-flops, each for digit 0, 9. So a flip-flop is represent a digit 0 to 9, and there are 10 flip-flops which represent a digit from 0 to 9. Only one flip-flop is on at a time, others are off. Suppose if I have to represent decimal 7, then 7th flip-flop is on and others are off, and other flip-flops are off. and that represent 7 digits. So storing a number like 735 means 7 flip-flop in first ring counter is on, third flip-flop in second ring counter is on, and the fifth flip-flop in third ring counter is on. And each of these rings are the part of accumulator unit. As you know, accumulator is a type of register, and inside the accumulator there are flip-flops and ring counters. Each ring counters, ENIAC had 20 accumulators. Each accumulator had 10 ring counters, one for each digit, 10 decimal digit, 10 digit decimal number. What a ring counter in ENIAC? Ring counter is a group of 10 flip-flops. If there is a 10 flip-flops, then 10 flip-flops combined make a ring counter. Is to store one digit decimal 0 to 9. One ring counter stores one digit 0 to 9, and one ring counter is made up of 10 flip-flops. So only one flip-flop is on at a time. Its position represents the digit. Accumulator 10 decimal digit. Each accumulator could store 10 digit number like 1, 2, 3, 4, 5, 6, 7. So it needed 10 separate rings counter, one for each digit. Therefore, ring counters per accumulator 10. Total accumulators in ENIAC 20. So there are 200 ring counters total, and these accumulators are used to store numbers. And one more thing, we use magnetic dumps to work as today's modern computer RAM as well as storage device. Temporarily holds data by writing zeros and ones in the surface of magnetic dump. We magnetize the surface so that if there is magnetization, then it represents 1. If it is not, then it is 0. And that's how we store the data in magnetic dump. Output. When the accumulators need to send the data out, it checks which flip-flop is on in each ring, sends binary encoded pulse back to the output unit via card punch or printer, etc. So it does opposite of the input in decoding. So this is how the working of a first generation computers actually work. Actually, it's more trickier, and we do not need to get in depth in this topic because, and in one video, it is nearly not possible to cover all those topics. So there's few things that we have to know is that about the register, like what is register, and what is accumulator, and what are the flip flop, how flip flop works, and what are the ring counters. So yeah, accumulator is a type of a register, and inside the register, and there are 20 accumulators. That means 20 registers, and each registers have 10 ring counters, and 10 ring counters have flip flops, and those flip flops are used to store one decimal digit. So this is an overview of how the first generation computer works, and it is not possible for me to give you whole context, like how inner working, how are the inner workings, how, because the first generation computer are very itself is very big complex topic. So I just try to give you an overview that how everything works in first generation computer. Moving on forward, we have advantages. So first advantages are pioneer modern computer. They were the first electronic programmable computers. This marked the beginning of digital computing history. And indeed, the first digital computer is our great ancestor of our today's modern computer. So, and these computers are indeed faster than mechanical devices, much faster than earlier machines like mechanical calculators or punch card tabulators. Could perform complex calculation. They could perform thousands of additions or multiplications per second, which was a huge breakthrough at that time. Programmable. Early use of programming via switch boards, the boards of machine language instructions. Used for scientific and military applications. Used for ballistic calculations, weather predictions, and code breaking, etc. Led the foundation of later generation. Concepts like CPU, memory, input, output, and store program architecture emerged in this generation. But the first generation computer had some limitation also. Everything is not perfect, and the limitations are use vacuum tools. Vacuum tools consume a lot of power, generated excessive heat, and were prone to frequent failures. Unreliable and overheated machine would often break down due to tube burnout. An ENIAC computer has 17,500 tubes, very large size, took up an entire room. ENIAC weighed 30 tons and covered 1,800 square feet. Slow input, output, and processing by today's standard. Input output via punch cards or paper tape was extremely slow. Manually programming. Programming was done using machine language or writing keyboards. No compiler, no high-level languages. Limited storage. Memory was very small, few hundred or thousand digits, and used technologies like multi-thumbs or delay line memory. Very expensive. Cost millions of dollars to build and maintain. Only government, militaries, or large institutions could afford them. No portability. Immobile and massive. Not suitable for general business or personal use. So these are the limitations of first generation computer, and that's all for today's video. Thank you.